Okay, this might be working. Yep, it looks like it is. Awesome. All right, so kind of like the title of what this says, we are stuck in a winter storm right now. Winter storm Izzy is outside, and we have probably about 8 inches of snow. That doesn't sound like a lot for probably most of the United States. However, we're in South Carolina. We don't really get snow. We get snow maybe once every 2 years, and at most we get maybe about an inch, and we get a lot of ice more than anything else. So we're closed. It's Sunday. We're closed anyways. We're probably going to be opening up half day tomorrow, maybe even closed tomorrow as well. So just to kind of kill some time, because I can't really do anything today on my day off, we're going to do just some refurbs that we have here, some MacBook Airs. I know it's been a while since I've done a live stream. Just work has been very, very hectic, which we've been very fortunate for. That's always a great thing. So I appreciate you all being patient while we still work on just running our business to kind of postponing the live stream. So got myself some coffee, and we have some marshmallows in it. Doesn't taste how I thought it would taste, but it's all right. So let's just kind of move forward and see what we have today. So I brought 2 MacBook Airs that we've had for refurb, and the only notes I have on them is that they need logic board repair. So let's go ahead and take a look and see what exactly is going on with these guys. And we have a new setup here. So I have OBS running on my MacBook, which has Windows 10. It is amazing the performance that you get out of a Windows operating system with OBS than you do on Mac OS. Let's see. So things are going to be a little on the fun side here. There we go. Overhead camera. So yeah, this one looks like we've had it for a while as far as a refurb. This is just a computer that we bought back from a customer. They didn't want to invest the funds into doing a board repair, so we just bought it back from them. And we bought it back from them a while ago. So truthfully, I don't know what is wrong with this one. Just kind of pull it off of our refurb bench that we get to whenever there's some downtime. And we'll see what's going on. Oh yeah, it's been pretty cold today. Me and my wife tried to take a walk down in the road, and it's about 24 degrees outside. If anything, it just really hurts our face. We're just not really used to the cold weather. Not here, at least. Okay, and this one screw didn't want to come off, so I'll set that to the side. See what we got going on here. So, to the naked eye, I can see that we have some rust here. See if I can flip this over into my Microscope camera. And it's a rust on a coil next to the CPU. And we have some corrosion right next to some capacitors. We definitely have some corrosion in our SPI connector. Some corrosion around our backlight circuit. Cool. Okay. So this one definitely was liquid damage at some point. So let's pull out the drive. The battery is already disconnected, and we're just going to hook it up to our power supply. Now, I don't have any of my fancy meters here on screen like I do over at the store. So my multimeter, you're going to have to trust me on my readings, as well as my power supply, you'll have to trust me. This is just my generic power supply that doesn't have the USB readings that connect to our computer. So now that we have that connected, let's see what we get. So the first thing I notice is that we're not getting anything on the charger. Let me make sure that my cable is connected properly. And we're getting 0.013. So that's a pretty low reading. That usually is an indicator that we're either not getting any power from our PPDC in, or we're going to have potentially an issue with our PM Sleep S4L. However, usually when we have an issue with PM Sleep S4L, we tend to have a little bit higher of a amperage consumption, something closer to about 0.1 amps. We have 0.013. So this computer looks like it's not doing anything. Just to make sure I'm not going to waste any time, I want to make sure that our CPU is not shorted. So what I'm going to do is measure these coils right here to the right side of our CPU. That's where our CPU phase chips are at. It's just basically the power supply for the chips. And this will kind of give us a resistance, a reading of our resistance to ground on our CPU. So with our multimeter connected, we got about 14 ohms resistance. So that seems to be pretty normal for this unit. So I think the next step we need to do is just pull out the board and check and see if there's any other damage underneath. Yep, let's go ahead and get that started. Still not used to this setup as far as streaming goes. On top of it being snowed in and having a new setup here running Windows instead of Mac OS on my MacBook here, I also don't have my glasses. I seem to have misplaced them, and I figured that I could probably just do the stream without them. So if you see me squinting, or if I have like a resting anger face, it's not that I'm actually upset, it's that I'm just trying to see. So yeah, let's pull the fan out first, and then we'll work on the logic board from there. And it looks like the fan actually wasn't even connected, so someone may have already pulled this board out at some time. And very well possible that someone could have been me, could have been another one of my technicians. It looks like we've just had this one for so long, really don't know what's going on with it. And once again, this is a refurb. This one's not a customer device. We usually have refurbs as a back burner repair whenever there is nothing to do at the store. And there's always something to do at the store, so we never really get to touch refurbs that much. Alright, today's kind of an exception since it's Sunday. Sunday's my only day off. And I'm not going outside. The roads are too dangerous. My car definitely can't drive in the snow. So, we're just going to do a board repair. The wife is passed out next to the fireplace, just trying to stay warm with the dogs. So I figured I would try to entertain myself as well. Looking at it, the bottom side of the board looked perfectly fine. However, my naked eyes are a little bit handicapped right now, since I don't have my glasses. So we'll take a thorough look once we remove the MagSafe board. Now, I recently got some more cameras that are coming to the store so that I can have two different live stream setups, one at the store and then one here in my home office. And we're actively looking for another level 2 technician right now. And once we find the perfect candidate, I'll be able to start doing more live streams again at the store. I've just been a little busy doing everything else but board repairs. Okay, so interesting thing is now we are getting 0.5 milliamps. So we're consuming about half an amp right now after we pulled it out of the case. So either we're having a partial failure here, potentially around the SPI connector. I've seen that do some funny things. Or we have something else going on inside of the top case. Potentially a trackpad issue, because the trackpad does communicate with our SPI. for fun, I'm just going to reinstall this back into our top case and see what's going on. And I'm going to reconnect the trackpad, but first I'm going to remove the battery. The battery on this model, fortunately, is only held together with 5 screws. It just makes for putting the trackpad cable, the IPD cable, a little easier. The input device cable, if you're ever curious what that abbreviation is for. Alright, trackpad looks okay underneath here. And let's float our DC board back in and just have our trackpad connected and see if that's going to pull down our sys1 wire. And that looks to be exactly what's going on here. So now I have my MagSafe 2 connected back with our DC board, and we are consuming 0.015. We're going to disconnect that, unplug our IPD cable. And we are getting 0.5. So something with the trackpad, whether it's the IPD cable or the trackpad itself, is preventing our MagSafe from talking to our SMC. Let's take a look here underneath the microscope and see exactly what's going on with the trackpad. And got to switch over to the microscope camera. So the trackpad is actually responsible for a lot more than just the trackpad. It also has 2 different modes. It has a USB mode and an SPI mode. And this is really good to know whenever you're diagnosing something. Your USB mode is going to be when the computer is turning on and it's in just like the BIOS screen, the EFI screen, which is whenever you hold option, like the option boot menu. Your computer, the MacBook Air, is technically using there we are. I'll show you in here in a second. But technically, the trackpad is in USB mode whenever you're like in the option boot menu or the file vault, or even when you get to the user account login screen. Before you actually log into the computer, your trackpad is using USB connections. But once it logs in, it then switches over from USB to SPI connection. SPI is just a fancy BIOS, a fancy UEFI on a MacBook Air specifically. But this is good to know because the trackpad, being that it communicates with the SPI, it can also prevent the computer from turning on. Our SPI is one of the main chips responsible for generating our PM Sleep S4L. And if our SPI is not communicating to the processor or the system management controller, then the computer itself just will not generate PM Sleep S4L, and that is one of the first signals that needs to be generated before we start getting out of our S5 states to our S4 or S3 or S0. So now that we have the trackpad removed, or not removed, but the IPD cable, the input device cable, we can see there's a hair bit of corrosion right there. So I'm curious if that little bit of corrosion is enough to make the whole MacBook not turn on. Now, the logic board still is dirty, so we're going to clean it up and remove whatever components look bad. And then we'll see if this one actually boots up to like a login screen. Now, I don't have a replacement IPD cable with me here at the home office, so if this fixes it, we're not going to leave this like this. If just simply cleaning fixes it, we're not going to leave it like this. We're going to end up replacing it, because if this is going to end up being a refurbished computer, we want to make sure that this computer never comes back when we sell it to the customer, because we want to ensure that this is a quality device. Now, refurbished computers is just a small part of the business. That is not our main focus. Our main focus is repairing instead of replacing. But eventually it comes to a point when a device is just so far repairable, irreparable is the word I'm looking for, that you can't really fix it at an economical point. So it just makes more sense to replace. And sometimes buying new isn't really always the most economical. The new 14-inch MacBook, for instance, that just came out 2 months ago, is right at $2,000. My first car was $1,000, just to kind of give an idea how expensive that is. All right, so now we have our IPD cable plugged back into our trackpad. Let's connect. We do get a green light. We're getting 0.5 amps. So that tiny little bit of corrosion on the input device cable going into the trackpad was enough to prevent the computer from not turning on. Now, I wouldn't consider this a repair. We would not send this out the door in the condition that it's in. We still have some oxidation and corrosion on our SPI connector, and then there's just a couple of capacitors that look a little bit suspicious, so we're just going to go ahead and fix that up, kind of clean up, remove corrosion, and if capacitors are bad enough, we're just going to replace them. If we were to send this, let's say this was a customer device. The customer comes in, and we just kind of touch up that cable, send them on their way, there's a very high chance they're going to come back. So we're going to clean up what we can to make sure that this MacBook will continue to live for many more years to come. So let's go ahead and start working on that. Where's our camera here? There we are. Hi, Corbin, working from home, I see. I'm not sure who Corbin is. Unless you think that may be my name. My name is Esteban. Or Esteban. It is Spanish for Steven. Let's pull the Wi-Fi card out. We're also going to pop off this guy right here. Good to see you, Pedro, though. And the question is do we have a flat blade for popping this off? We may not have one here. So we'll just use the flat end of a black stick. That might not be flat enough or sturdy enough. How about we just use a flat head and gently pry off the side? The downside I have found from working from home is realizing that I need more tools here that I have at the store that I don't have here. Like one big hindrance and that I have here is my thermal camera I keep at the store. Just because those Keonlee thermal cameras, they're pretty expensive. And I don't really want to, at this moment at least, invest into having a second one strictly for the home office. But if we get too busy, we may have to. But right now I can't really justify having a second one of those cameras. Okay, let's look at everything under the scope. Oh, sorry. No, it's fine, Pedro. I normally don't, I guess, announce my name in the beginning of the videos. And I used to wear a shirt that had my name embroidered onto it, but I don't do that anymore. And let's try to get this camera working. This is also a new camera that I have here. So the first thing we're going to do is just pop this guy off. Pop off this dirty, dirty SPI connector. And for that, I like to use a mix of my hot tweezers and a rework station. So let's turn on our fume extractor. Get a nice sip of coffee. And adjust our temperature. So I'm using a different type of rework station here than I do at the actual store. I'm using a tin or Atten, the ST862D. I actually got this one from store.rossmann Group. and I like it. It heats up really quick. The only qualm I have with it, and I'm sure if I read the user manual, it would tell me how to fix this, is in order to turn it on, you have to press a button that's on the handle. And I like my my quick rework station where I just lift it up out of its like base station and it automatically turns on. I'm sure there's a simple setting. I probably had to press 2 buttons to get that feature to work. And dog's whining at the door. She hears me, but she can't see me. Now we're going to wick that up so we don't have any of the connections bridged. Another thing is I don't have an ultrasonic cleaner at home. So I'll be able to clean up the corrosion with my iron, but I won't be able to give this one a bath. Not here at least. I'll have to bring this one back to the store. So there are pros and cons in having a home office. The pro is whenever I'm done with a board repair, I can just walk 10 feet to my bedroom and go to bed. There'd be times where I would do board repairs at the office until maybe 2 a.m. at the actual store, and then I would drive about another 20-30 minutes home, then wind down, then go to bed. But then the con of having a home office is that all my tools are at the store. So there's a nice fine balance of knowing what I can and can't do here. For some reason, this is not really melting. This iron is acting a little funny. Let's make sure we have it plugged in properly. We do. We have the temperature set to the right. This handle could be going bad. Let's see. No, melted that solder just fine, so let's try wicking that up again. But I thought it'd be a smart idea when I went out into the snow this morning and try to make a snowball with my bare hands, because I don't own gloves, because it doesn't get cold enough to wear gloves here. And oh, my hands hurt for probably 10 minutes straight. The worst part was my hands were wet even after I put them in my pockets, so if I ever pulled my hands out of my pockets, it just hurt. The wind itself just really, really hurt. Alright, let's see what else we got here. RIP SPI connector. You're not wrong. Older Keonlee cams going for about $315 on UR. That's not bad. I paid close to about $800 for my first one. Alright, all this we're going to take care of as well. What is UR? Union repair, right? Okay, so we're going to replace all of this. So this is going to be the circuit that is responsible from getting power either from our PPDC in, straight from the charger, or from the battery. And this just could look better, so we're just going to kind of repeal and replace, as Lewis would say. So let's switch back over to our tweezers. Okay. Put some flux on this area and just kind of pluck everything up. I'm going to also raise my temperature here. I've also seen some technicians use handheld thermal cameras. Alexi, or his name on Rossman Discord is Inwarp. He has a handheld one that he uses, and that would be pretty interesting to explore with, because with the Keonlee you have to put everything underneath the camera. You can't really just point it at something to get a good reading. It does its job. It definitely has improved workflow for me and has cut down on time. But I know there are other cameras that exist. And I want to say I see that iPad Rehab sells a thermal imager like iPhone adapter. Just plugs in through the lightning cable, a lightning port. And for fun, we're gonna also replace this big guy. He's probably fine, but he was very close to our oxidation here. And he smelled bad. I think he just exploded. This guy right here looks a little on the suspicious side. Yes, I didn't want to be spamming. Oh, you didn't spam at all. Oh, like for a link. Gotcha. I appreciate the consideration. I haven't ordered anything from Union Repair in a long... Actually, now that I think about it, I've never ordered anything from Union Repair. I have an account with them, but I remember trying to get something, but what turned me away was the shipment time for a very specific repair I needed to do. I'll have to check that out though. If they're selling them for about $3.15, then I can justify that cost to invest to keep here at the home office. Thanks for sharing that information. And these components over here, they're probably okay, but since they have oxidation on them, being that this is going to be a computer that we're going to sell and back it with a 1-year warranty, even though we say 1 year, we still take care of customers way out of our warranty. We want to make sure this is a good computer. No chance of it randomly coming back. The fear I have with mail-in repairs or refurbished computers is that we'll fix them up and then the customer is out of state and they have an issue and they have to deal with mailing it back, and that's just a whole logistics nightmare for the customer. If I wouldn't want to deal with that, I don't want to put that that same inconvenience on the client. And you might be able to hear that, but my dogs hear me and they're all barking now. Either that or they see someone walking in the snow. Alright, so now that we've wicked the area, let's just kind of go over real quick with some new solder. So that way when we put the components on, they should go on a lot easier because we're using a low melt solder. And for the purposes of having a clear video, let's clean this up. This camera, it's a Hey. It's an alright camera. There are better cameras out there. But the exposure, the auto exposure, doesn't like to play well when there's, I guess you could say, reflective light from the flux. So cleaning it up makes it a lot better for viewing purposes. Okay, so now that we have this area nice and cleaned, let's go over to our donor board and take replacement parts. Let's see. And which donor board looks better? It looks like we've already borrowed the 3.42 generator from this side. And we're missing that capacitor right there. So I think what we're going to have to do is borrow from both. Yep. That will be the plan. So we'll take most of the components from here, and then these two, I want to say that those are capacitors. We'll end up taking them from this board because it looks pretty okay on this side. Excuse me while I just have a sip of my coffee. Now this board is a different board. It's an 8203437, and the board that we're working on is an 820-00165. This specific circuit for power going into our PP3V42 generator, it is the same on both MacBook Airs, so we can borrow from either interchangeably. So let's start with this capacitor up here in the top. Thinking back to the trackpad and having corrosion on the IPD, the board we're working on was definitely liquid damage, but I had a customer come in earlier this week, and she had a very particular issue that I saw was really, really common in the middle of 2020, early 2021, where she'd used Clorox to wipe down her MacBook Air, and then all of a sudden she had an issue where parts of her keyboard weren't working. Now, normally you would think, okay, this might be a defective keyboard. I may have got some liquid damage inside of your keyboard. But in her situation, it was that when she cleaned her MacBook Air, the chemicals or the moisture from the Clorox wipe had actually soaked through the cracks where the trackpad's at and just rested on the IPD cable for a while, and where the IPD cable went into the trackpad. Now, this is important to know because the trackpad is kind of the bridge, the daisy chain between the keyboard and the computer. So if you have any oxidation, any corrosion, just any damage to the trackpad, it will also experience issues with your keyboard. So she came in wanting to have a keyboard replacement. Instead, just judging from past experiences I've had, went ahead and opened up the board or the computer, and we pulled out the battery, got to the IPD cable, and I was able to explain to her that she actually had corrosion on her IPD cable, the cable to the trackpad, and just educated that the trackpad is also responsible for keyboard functionality. After we'd replaced the IPD cable, and we gave the trackpad just kind of a detailed scrub with some isopropyl alcohol and an electric toothbrush, her keyboard was working perfectly fine after that. That is all that she needed. So one thing that I saw a lot just from people sanitizing their computers for the majority of last year was Clorox or just sanitization wipes can go through your trackpad cracks and can actually get on the cable or the trackpad itself and will cause all sorts of funky issues. Oops. Don't blow away, mister. Come back here. But that was a really fun learning process to show some of my technicians. Where'd you run off to? Nope. Hold on. Lost him. There you are. Hey, Sean. At least you kept all the snow up there in Greenville. Just got some rain down here in Charleston. I remember a few years ago when I was still living in Charleston, it snowed randomly. I want to say it was like 2015, 2016. And we were really, really confused. Yep, all the snow is stuck up here. None of it's in Charleston, fortunately. Alright, we're going to cheat. What we're going to do is we are going to touch one of these legs. I would love to be in Charleston right now. I need a vacation. I'd like to go down for a few days. There we are. So you went back to your home, but you're trying to fly away. Alright, let's keep moving. Well, I guess the moral of that story I was teaching, if there was anything, or talking about, if there was anything to learn from it, it's that if you want to sanitize your computer, what I would recommend is using a paper towel and a high-grade isopropyl alcohol. 99% preferably, but if you can't get that, try 91%. And just dampen the paper towel and just kind of wipe down the aluminum surfaces of your MacBook. You can even go over your keyboard. Avoid the screen. The screen more likely will have an anti-glare layer that does not like chemicals, and it will look really, really bad if you wipe it down with Windex or alcohol. But a high-grade isopropyl alcohol for sanitization, and go over the aluminum parts of your computer. The Clorox or sanitizer wipes might be a little overkill. Speaking of overkill, let's increase the temperature here. It might be just a little bit of overkill for your devices. Come to think of it, I think we've even had a couple of phones come in with liquid damage from people just soaking their phones in Clorox wipes, because those wipes they hold a lot of moisture, and I'm sure there's traces of water in it. But the benefit with 91% or 99% isopropyl alcohol is the water content is so little, it doesn't really have time to oxidize or corrode anything. And it's not really conductive. It evaporates too quickly. Love to be in Charleston, but then you wouldn't be snowed in streaming live fixing a MacBook. I just hope the snow is pretty much gone by tomorrow. That's all. No, South Carolina is so bad when it comes to handling snow that we are in a state of emergency right now. Our governor, Henry McMaster, issued the state of emergency 2 days ago, and it started yesterday at 3 p.m. Now let's take this capacitor here. And you may have noticed I switched from having normal tweezers to hot tweezers for the capacitor, just because it's a bigger component. Alright, so now that that's being held in place, let's toast it the rest of the way with our workstation. I actually picked up a MacBook Pro M1 2020, hoping no issues in the near future. From my personal experience, I haven't really seen a common issue on that model. I have heard reports, now this is just reports, that the firmware for the SSD, how it reads and writes, isn't properly configured to where the SSD is constantly reading and writing. And like traditional SSDs, you're only going to have so many read and writes before the NANDs just stop reading and writing. So I've heard, it's not trying to scare you, but this is the only thing that I've heard, is that the M1 could potentially run into having dead SSDs in the future. Now that's something that only time will tell, since the M1s are still new. Just kind of messing around with them. They're nice machines. They are fast machines. Apple had a goal and they set that goal. The only thing that I've seen M1s in for have been liquid damage and screen replacements from people breaking their screens. It's all been accidental damage. I haven't really seen any weird manufacturing issue that previous models have had. Because every MacBook kind of has its own quirk. And I've yet to really see anything with the M1s. Can attest that I've had someone spray Windex on their MacBook Air display, borked it because it dripped in. Yep, and that's just because of the amount of water content that is in the Windex, which is why I'd recommend if you're going to use any cleaning, put it on a damp paper towel. Never spray directly onto the computer itself. But that is just from my experience. No, I do have customers come in all the time and they ask how do we clean our computers, and we keep a bottle of Windex with a paper towel, and then we also have a bottle of 99% isopropyl alcohol, and we'll just put it on a paper towel. And it's not a normal paper towel, it's like the blue Scott paper towels that you can get from the automotive section. Just because they're a little bit more coarse, they pick up grime a little bit easier. But you can use it with a normal paper towel as well. Even a magic eraser. You can put a little bit of Windex on a magic eraser and go over the aluminum, and it will polish it up pretty nicely. Borked it, doggo? Yes, there is 3 dogs outside my door. I had to keep my office door closed because for some reason it is about 10 degrees colder in here than it is in the rest of the house. The SSD is soldered on that model. Apple started soldering every single SSD beginning in 2018. Yes, 2017s had soldered on SSDs, even 2015s had solder. MacBooks in 2015 had soldered on SSDs, but in 2016 and 17, Apple still had the non-touch bar, which had a removable SSD. That was the very last MacBook that had a removable SSD. But officially 2018, every single computer that Apple has made, laptop, every MacBook Air, every MacBook Pro has had a soldered on SSD. Let's see if we can pick that one up with just hot air. Still getting used to this rework station, so I gotta figure out what temperature properly melts. This one looks like it could use just a little bit more heat. Let's do that. Let's turn up the heat just a little bit more. Come on, buddy. There you are. Alright, so we have to use just a little bit more heat on this one. Your tweezers look a bit dirty there. Yes, they are. That they are. Let's see. Yep, I got some caramelized flux on the tips. It adds character. So I hope everyone has been having a good start to their 2022. Alright, that guy just kind of went into its home. Everything looks nice and solid here. So all of this flux, we're going to end up just replacing or cleaning this in the ultrasonic cleaner at the store. So right here we have some oxidation or some corrosion buildup right next to these capacitors. But these capacitors still look perfectly fine. They don't really look oxidized. So what we can do is just touch up that corrosion with some high-grade isopropyl alcohol, a Q-tip, and then we're going to add some new solder onto these sides. But these capacitors don't look like they need to be replaced. So this board repair, there's really no logic to it. I haven't even had to pull up Flex Board View for looking at the schematics for troubleshooting. This one has been what I hear the term people use is janitorial work. We see dirt, we see corrosion, we remove, replace, and clean dirt and corrosion. So kind of like I hear the Facebook group, the board repair Facebook group, call this janitorial work. So there are some board repairs where you really don't have to think. You just have to find the corrosion and just replace the dirty parts. Lewis would say not enough flux. You're probably correct. Let's get this area nice and soldery, if that's a word. If that is an adjective. No, Lewis would be complaining about the New York real estate agents. Greenville, or I should say South Carolina, is not much better with our real estate market because what's happened is all the New Yorkers have been flying down here. Just to kind of give an idea, my wife and I are very familiar with the housing market because we just closed on a house less than a year ago. But when we were looking for houses, houses were going in our area for about 180, 200,000, on the high end, 250,000. We went back and we looked at the same neighborhoods. Now that we're nice and settled in, we own a house, and the same neighborhoods are now selling their houses that they were selling originally at 200,000, close to 300 to 350,000. So things have gone up 50%. It seems, because we have so many out-of-state people moving here because the cost of living in South Carolina admittedly is lower, but that has unfortunately put a lot of people in a hard situation when it comes to buying homes locally. So the housing market is really not... It's a good time to sell a house. It's not really the best time to buy a house. All right, so this guy here. This is a coil. It's just a piece of wire that's wound up. And this is just rust. However, I would hate, absolutely hate, to sell this computer with rust on a coil, and someone goes to another repair shop and they say, oh, I sold you a bad logic board, there's rust right here. Being that there's rust on the coil is not going to affect the performance of the computer. It's just not pretty. For aesthetics reasons only, we're going to replace this component. Just got to make sure our tweezers are big. Same thing is happening here in South Florida. I can only imagine. My future brother-in-law is from South Florida, and he's expressed to me that there's a lot of people that are moving there as well. It seems like all the big cities, there's like a grand exodus of people living or moving out of the big cities and kind of finding the more southern or rural areas to move to. The big thing, and it's a pet peeve of mine, and I probably talk about it to my employees way more than I should, is people coming down here and deliberately buying houses and then renting them. not even like selling them, just renting them, and renting them at really high prices. Like, people are renting houses in our area for $250,000 a month rent. Of course, I know it's a different time, but just to give an idea, when I was renting here in Greenville before I moved to Charleston, I had a 3-bedroom townhome for $900 a month. And the fact that people are renting out houses at $250,000, you know, what why don't you just buy a house if you're going to be spending that much and throwing money away instead of, you know, being able to build equity on it? It's a subject that I could go on forever about, and I'm just not going to do that right now. But it's good for the local economy. We have a lot of people moving down here, and it is growing our infrastructure more. There are more businesses that are opening up. It's just for the people who live here in Greenville, who have grown up their entire life, you know, trying to save up money to get a house, and with the idea that, you know, you can get a house here for about $150,000, $200,000. One of my best friends, he bought a house many years ago at only $100,000, but now the houses are going for $300,000 to $500,000. It seems, you know, Lewis did a really good job explaining that carrot of getting a home, getting financial stability is getting further and further for us locals. It's a lot easier for the people who are out of town because they probably made a little bit more, had some more money saved up, probably sold a house at a lot higher price in a better market. But it's discouraging a lot of locals. That's the last thing I'm going to say on the subject here for Greenville. And I know Charleston's not much better. I know when I lived in Charleston, houses were going for about $300,000, $350,000. So if Greenville is as high as it is now, I can only imagine what Charleston is now. Okay, so we got our new coil. Oh, I just realized that the camera looks a little funny through OBS. I do have a new 0.35 C-mount adapter. I just gotta configure it or get it in the right position. You know what? Actually, we're gonna kind of cheat on this one. So what we're gonna do is we're gonna wick up these pads, and then we're gonna put the coil on top of the pads and then apply solder to both sides of the coil. And still kind of work with this C-mount here. Hopefully that looks good. I really do like working on the MacBook Pro Retina models and the A1466 MacBook Airs. Something about them. I just really enjoy working on these, but they're starting to become less and less popular since everyone wants to jump to the M1 computers. But these have a special place in my heart. I personally have a 15-inch 2015 MacBook Pro, and that's my daily driver. That's actually what I'm doing the stream on right now. I love that. I like that computer. Still running macOS Mojave because it has 32-bit support, and I still have 32-bit software. That is the old one. Let's get rid of that. Where's the new one? Where'd the new coil run off to? Uh-oh. Mr. Coil. Uh-oh. Hopefully it didn't get sucked up into the fume extractor. No. It's literally right here in front of me. Okay, back into the scope camera. Alright, so now that that is positioned, let's go ahead and take our big iron and touch the pad that the coil is on and run some solder on top of that pad so that it can grab onto the side of the coil. And this iron's not getting as hot as it should, so something tells me either this handle is dying, or like the element in the handle is dying, or the tip is dying. So let's switch back over onto our tweezers. Come on. You're going up the tweezers, but I need you to... Oh, you're kind of grabbing. Not the prettiest, but we're gonna touch that up. There we are. Nope. Quit spinning. Please quit spinning. Either that or the heating element in general in my soldering station is dying. It seems like it's taking a little while to heat up this coil. Alright, let's switch back just to see if we get any difference. Sorry for the pause, the intermission here. Okay. So, one completely random question, but kind of referring to the snowstorm. What is it about snow that makes people want to buy milk and eggs? Sorry, bread. Milk and bread. I used to work at Bilo back in college. My wife used to work at Ingles, local grocery stores here. And what is it that whenever people hear that there's about to be an inch of ice or snow, people find the need to just buy all the milk and all the bread? Because I think whenever there's going to be a snowstorm, I anticipate for a power outage. And milk will only stay good for so long. I mean, yeah, you can keep your fridge closed. And the argument I have people tell me is, well, you can put your milk outside in the ice. But who is out here eating milk and bread sandwiches? And the other wild thing, because admittedly I went and I got some non-perishables just to stock up just in case. Yes, these tweezers aren't even on. I went ahead and I bought some canned food, some soup, some like Chef Boyardee. Yeah, no, I have a grill with a burner on it just in case I need to heat up some canned food and some canned vegetables. But with all the bread being gone, the peanut butter aisle was fully packed. Like, if I'm going to be eating some bread, I want some peanut butter and some jelly with it. But no, it looks like people are just eating bread, unless they're making like turkey and ham sandwiches. That coil looks much better. Alright, let's see what else. But no, if you go to the local grocery store, of course they're all closed right now, all the bread, all the milk is gone. And on top of that, I went just to kind of get some dog food for my Dachshunds. And all the meat was gone too, except for sausage. People won't touch sausage apparently, but all the beef, all the pork, all the chicken is completely gone. Once again, you're planning for potentially a power outage. Why are you buying the most perishable things? Let's see. I lived in New York for most of my life, and the question still keeps me up at night. I just feel like it's some sort of urban tale. Just as much as whenever you get your device liquid damage, throw it in rice. That's just something that everyone knows inherently. And no one has to Google that. They just know, throw it in rice. Which, please don't throw your devices in rice if you ever get it liquid damage. The longer it's in rice, the longer it has time to oxidize and make things harder for bringing back to life. But that's kind of what I think happened is someone's parents told them when it snows, get some milk and bread, and their parents' parents told them to get milk and bread, and their parents' parents told them to get milk and bread. So it's just been like this old tradition to just get milk and bread and apparently chicken thighs. Someone was complaining to me yesterday that they couldn't find chicken thighs anywhere. I mean, to me, it makes the most sense that if you're going to plan for there to be no power, something like Chef Boyardee is the way to go, because it's already prepped and ready to cook. Or I shouldn't say cook, ready to warm up. It's already cooked. It's, someone used to tell me it's prepper food. Oh, all the pizza was gone? No. And all the ramen was gone as well. So people are just out here living off of milk, bread, ramen, chicken thighs. Alright, so the component I'm replacing right now is going to be the SMC Reset Switch. So this is what's responsible for creating power that goes to the SMC to turn on. And so it just looks gross. We're just replacing all the components around here. I think this capacitor will be fine. Now let's just clean everything up. So we're gonna wick up the old solder if our iron wants to. Yep, there we go. The coldest I have ever experienced was 4 degrees in Ithaca, New York. The upstate New York. And that level of cold for me, being from the south, it was so cold that it hurt my face. And I was only out in it for maybe 5 minutes. I was actually trying to get on an airplane. I was visiting a friend who lives up there. And yeah, 4 degrees. And it felt like someone was taking a razor blade to my face. It was not pleasant. I always thought I could live somewhere cold. But I think the problem is I got too much Hispanic blood, too much equatorial blood. That my genetics physically cannot tolerate being in anything that cold. All right, so fortunately this one looks okay to take parts from. Let's see. There's just a little bit of oxidation on one of those pins, but it doesn't look like enough to damage anything. Well, if the computer doesn't turn on after we replace this, then we would know that this would be a bad chip. Do we have another donor board here? Nope, this is the only donor board I have that actually has an SMC Reset Switch. Yep, just get a little camping stove and you're good to go. Yep. Someone in Discord actually showed me that they were able to generate power using, what was the word they used? I think it was a pillar, man, I'm gonna have to look it back up, but it was some sort of cooler that has a whole bunch of transistors built into it, and it generates power. I'm gonna butcher this saying it. Power by using extreme temperatures. One side of the plate would be really cold, the other side would be really hot. There's really cool videos. Actually, oh geez, why can't I remember what it was called? I shouldn't have even mentioned if I can't remember what it was called. But they were able to generate electricity just by heating up a plate and putting the other side in ice water. And they were able to generate 8 volts of power. Come on. Go into your home. And let's hit this up both sides with some solder with our tweezers. And then we're going to heat it up and let surface tension just pull everything back. And yeah, all we're doing today though is just a little bit of cleaning up. I do have another board. If we have enough time, we can check and see what all that one needs to come back to life. And that one's also another refurb that's been sitting in a refurb queue for a while. So I could not tell you what's going on with it. Yep, this chip just looks to be a little misaligned, so by just putting some solder here, the surface tension from the solder should pull it back into place. There we go, and everything just moved a little bit, so if that is in place, now we just need to replace these capacitors and resistors, and then this side should be good to go. Then we'll inspect the rest of the board to see if there's any other corrosion that we need to replace. Alright. So is this the donor? It is. Pardon me for a second. I have a little bit of marshmallows in my coffee. I thought that was going to be a little sweeter than it really is. It just tastes like coffee and marshmallows. Did not change the taste of it at all. I thought I would try to make it taste like hot chocolate or something. Okay, that one picked up really easy because there wasn't ground on the other side. This looks to be potentially for feedback. I'd have to double check by looking at the schematics. And what we're going to do is just kind of roughly transfer everything, and then we'll kind of heat it all up at the same time with our iron and make it all melt into place. And my tweezers here were manufactured a little weird. Bought these from Amazon. They're Hakko tweezers, but I don't think they actually are Hakko tweezers. Let's see. Did I transfer? Did I get the wrong component? Let's see. I did. Yep. Grabbed the wrong one, so let's put this one back. We'll use this for another day. Okay, but we need you. So one end of my tweezers are probably twice the size than the other side. The not the hot tweezers, but just the normal tweezers. So either they were manufactured wrong or this is not really Hako. I really like Dumont tweezers. They're just a little on the high side. I need to get some to have here. I think the last pair of Dumont tweezers I bought was around $40. But they're really, really nice. Really nice to work with. And this one's actually already missing something. Yep. So let's check and see if we have it on. No, it's not that it's missing, it's that it's not populated. Okay, so I'm glad we checked with another board because there's nothing to actually take from. So now we need to borrow this one right there. Let's take it from the same circuit that we're just borrowing parts from. So ultimately, it looks like this MacBook was not turning on because of some liquid damage on the IPD cable for the trackpad, and it was preventing the SPI from properly working. But at the same time, now that I think about it, we weren't getting a light at all on our charger. So something was being messed up with the system management controller as well. And by simply taking the unit out of the housing, and now we're going to replace that cable at the office, now it's working. We still have a pretty extensive amount of liquid damage on here. The thing is, by seeing that, it makes me think that this was not a customer device. This may have been one that we bought in bulk in the hopes of repairing. Because something like that, I'm sure we would have caught it. Alright, so everything is nice and in its home where it needs to be. Before I go any further, what I want to do is let this cool off for a minute, and then we're going to see if it still turns on, because we've transferred a lot of components here. And I've had situations in the past where parts that we borrowed from donor boards were defective. And so now that we've transferred a lot, I'm going to let it cool down for a second. We're going to hook it back up and see if we get booting amperage as well, which was close to about 0.5 on this unit. Meanwhile, let's just kind of go ahead and clean our area up. We don't want to have any of this wick kind of lying around. Oh, for some reason the camera had changed. So now we see a little bit of everything. What is going on here? Oh, I think it was always that way. We'll zoom in just a little bit more. Since I am using a MacBook Pro for streaming, I did have to lower the resolution on these cameras from 1080 to 720. So I think we're streaming in 720 as well. Because at the end of the day, it's still a laptop. Okay, let's feel. That's nice and cooled down, so that's enough for us to turn it on. So we don't want that stuck in the magnet. These MagSafes, they are magnetic, so any components that you take off might get stuck. So our SPI JTAG connector that we took off first was just kind of chilling on the tip of it. So let's see what we get. We have a light. We have 0.5 amps consumption. So it looks like this one should be turning on. So everything that we've replaced for cleaning up is still properly working. So let's take one last look at the board and see if there's anything else that needs to be repealed, replaced, cleaned up, make like new again. And then we'll put this in our clamshell, or in our top case, and see if this one will actually get to an option boot screen. That's nothing to really be concerned of. It looks like corrosion, but it's not. It's just like salt dust around this area. Looks pretty good around our CPU. This looks like it could benefit from just being touched up. Doesn't look like it needs to be replaced. So let's just touch it up with our tweezers. Actually, let's switch to our knife tip. How about that? Excellent. That looks much better. And let's keep exploring. See what we got going on. Our coil that was rusted is now no longer rusted. SPI connector has been properly replaced. Everything around our PB3V42 generator looks good. Battery, IPD, backlight, all that looks good. Oh, now that I remember, not backlight. That was keyboard backlight. So normal backlight looks really bad. So I'm curious if we even have a working, if this fuse right here for our backlight is still good. Let's get this in focus, and I'm going to have to adjust my camera, C-mount camera. Or C-mount lens. Okay. Yep. So let's grab our multimeter, put this in continuity mode so we hear a beep whenever the line touches each other, like that. Surprisingly, that fuse still is okay. So what we'll end up doing is we're going to replace, yeah, that's fine. We'll replace this guy, these two components, and we'll touch up this side of the fuse. Ooh, alright, even right there. Now this brings up a really good point that I need to look at. So we do have some rust and oxidation, some corrosion buildup here on our EDP internal DisplayPort connector. Or was it external? I forgot what the E stands for. But it's our EDP, our DisplayPort connector. We're going to have to look on the actual MacBook cable to see if that cable is going to need to be replaced. So we now know that's the next point of concern. Let's flip the board over and take a look here. All that looks good. Let's check out our SMC. Around it looks nice and clean. Ooh. Whatever this is, we're going to end up replacing that, and that looks like that's going to be something to do with our battery, just because it's on the other side of the battery, so you will get replaced. What else do we have here? So just a little bit more homework. I'm just jibber-jabbering longer than I should. Get this one nice and clean. We may just do this one repair and then save the other board we have in the future. Now this is something to be concerned with. This looks like someone has sliced the board. Something went across, either that or maybe that's where the liquid had gone through. But we have a clear line going across. Doesn't look like it knocked any components off from here to here, because that does look like top layer of the board has been scratched. But nothing is actually damaged. Alright, so main points of concern to address is now going to be our backlight and that battery capacitor. Let's go ahead and remove these three components. This MOSFET looks like two capacitors. And what we'll do to help cheat is we're going to switch back over to our hot tweezers, so sound advisory. And we're going to use heat at the same time. Alright, so there goes that part. Check the bottom one down here. Just yeet that one across the room. And that one is gone. And like all the other components, we're going to take our wick and just clean up the corrosion. Now, one of the pads down here is heavily oxidized, so we're going to actually have to scratch that with our scalpel to expose the copper so that we can apply new solder onto it. So, right there we can see that bottom one. Let me see if my camera, yep, you can see everything. So that bottom part right here, which looks like it may be ground, is just heavily oxidized, so our solder won't properly stick to it, won't melt to it until we scratch and expose part of the connector. And this right here, this is also another point of concern. This almost looks like a via. Maybe it's a test point. It is just a test point, it looks like. If it was a via, then we would have like a tiny little hole right here that would be going to the other side of the board. But it is just an oxidized test point. What we could do is just kind of scratch and expose some of the rust to remove it, but it should be okay. Now that I think about it, no, this is not going to be ground. This is going to be part of our backlight fuse, or our backlight circuit. So this is going to be our, what is it, PP bus in for backlight. I have to look up the exact name of the circuit on the schematic, but we definitely want this all nice and cleaned up. This, we could put a little bit of mask on it. I don't have any of that here, or a UV light, so we'll probably just end up doing that at the office just to make it look pretty. Aesthetics. Definitely going for aesthetics here. That hole looks worse than it actually is. Since it's just a test point, there's no functionality concern. Alright, and since it's in a tiny spot, what I'm going to do is use my hot tweezers this time and just feed solder through the tweezers as I go over those pads. And just touching up this side of the fuse. The fuse is just a wire that, if it gets too much amperage, will break. And it was still fusing, or acting like a fuse like it should. So that would explain whenever we took our hot tweezers, everything just came off really simple because there actually isn't ground on these sides. And ground acts like a heat sink, so as you apply heat to it, it disperses the heat just as quickly as you apply heat. And let's see which one. This one looks pretty good. Let's switch over to our other one. They both look good. So both of these backlight circuits look good, although that one capacitor up there looks a little suspicious. So we're going to borrow from these parts right here instead. So we actually don't need to use our rework station for applying heat, not until we get to this MOSFET. That's just going to allow us to put that MOSFET on a little easier, but we should be able to just simply grab this and just pick it up with our hot tweezers. So let's borrow you. And we're going to put you right here into your new home. And grab this little guy. The hot tweezers are one of my favorite tools. Definitely an investment, but if you're doing board repair professionally and you're doing mini board repairs, it's an investment worth considering. Alright, so let's grab this other one. Where are you hiding? Right there. The hot tweezers and the hot knife, or the micro knife. And we're going to put you here in your new home. Well, maybe. I looked away for a second and pinched a little too hard. It may be gone. Let's see. Alright. Yup, that one may have disappeared into the ether. Let's look and see if it's stuck in any of the flux. I always have a fear that if a component ever blows away, it's still going to hang out on the board and bridge a connection, but it looks like it's gone. It looks like it blew away. So we are just going to borrow another one and not squeeze as hard with our tweezers so that they don't just jump away. We're going to borrow you. Whoops. Drop my tweezers. My Hako tweezers. Okay, and let's try this a second time. It'd actually make it a lot easier for me if I were to take this MOSFET instead first. Just so I had a little bit more wiggle room with the tweezers, the hot tweezers. There we are. Okay, so before I move everything, what I'm going to do is grab my other Hako tweezers, and we're just going to position this. So let's... Oh, no, no, no. You tried running away again. Let's grab you. And now that it's semi-positioned, we'll put it back in its new home. And whenever we heat up this whole area, the surface tension will pull it together and make it look pretty. Now let's go back to the original one we were borrowing from, and we're going to take this package right here. I'll go ahead and put some flux over it so it's a little bit easier to maneuver. Get our rework station going and apply some heat. Now the last one I took, I used my hot tweezers for pulling off because I kind of cheated. Let's see if we can pull this one off with just normal tweezers in the rework station. One thing I do like about the tin rework station versus the quick rework station is that it heats up a lot quicker. I just need to figure out how to get it to automatically turn on when I lift the handle up. So again, I'm sure it's a really, really simple setting. I just need to read the manual. Alright, so that is nice and in its place. Let's kind of touch up these components we have here and let the surface tension pull it together. And now, before I forget, one thing you may have noticed just now is when I was moving the package off of here, I didn't move a couple components. I'm just going to put it back in its home because we may need these for another repair in the future. So I'd like to hold on to these components. Now, and it's cooling itself down. I got to press the button on the handle to get it to work again. Yeah, it's just one tiny thing I have to remember. It's different from the workstation I have. It's not that it's difficult, it's just different. Alright, so this will be for future parts. And let's see, so that looks a lot better. It's all nice compared to what it was before. Admittedly, I do have a little bit of oxidation on this component down here, so we're just going to touch it up with our hot tweezers with some solder, make it look pretty. Again, we're just doing janitorial work on this one. Alright, now let's go ahead and clean up the oxidation, the corrosion on the EDP connector. Let's try to get this in focus. And let's put our flux on it, and we'll go over with our hot tweezers and get this one all nice and spruced up. And we got a little bit too much solder on this one, so let's see if we can just kind of touch it up. Try to pull some of that solder off. Nope, instead it's going to bridge to the next bin. That's not a problem. We can get that. And just wick using the actual wick. How about that? So this one pin right here is just heavily, heavily oxidized. So just like what we did earlier with the pin, that pad for our backlight, what we're going to do is we're just going to kind of scrape into it, expose some of the metal, some of the copper. Yeah, you can see I can touch it and it wiggles. So that's not a good connection at all. So now that some of it is exposed, let's just dab it a little bit with some flux. And then let's get our hot tweezers again and just go over it and apply some heat and solder. Alright, let's clean this up just to kind of get a better look, make sure those pads aren't touching. I find that acetone for nail polish remover also does a really good job for cleaning up flux. Alright, so down here you can see looks like a piece of wire from our wick got stuck. So we're going to have to pull that out. We don't want that hanging out in here. We got it. Oh, and let's switch over to right here. We're going to hit this with some alcohol and just replace this capacitor. And I think that's going to be the last of our concerns. We'll put it in the top case, hold down the option boot, see if this one turns on. Actually, not just option boot. Well, we'll see if this one actually has an OS or an account on it. Well, now that I think about it, I don't have a test drive here. Because what we want to do, and we may have to do at the store, is make sure that the trackpad is working in both USB and SPI mode. Remember, we were having an issue with our IPD cable, so we want to make sure it didn't damage the trackpad in the process. Alright, and that pad, wow, that is really, really blurry for you guys. Sorry about that. And that pad is heavily rusted. The question I have is that a via? Let's get that in focus and adjust our C-mount. That one is a via. Alright, so this one has a tiny, tiny hole, and it goes to somewhere else on the board. So what we need to do is check and see if we have continuity. Probably not, because this is just kind of scraping away. Because we're probably going to have to run a jumper wire. So now we could either solder directly to that hole right there in the center, or we're going to have to solder a jumper wire. Let me finish exposing some of this, and then we're going to open up our Flexboard View software and see exactly where this via goes to. Alright, change over into our screen capture. Awesome. And this one was the A20000165. Let's change the view here. I'm using a Mac keyboard, so I have to remember what keys do what. There we are. And we're going to switch it over to Flexboard View, and we also want to fill in our part fill, our board fill, and the board's upside down, so we're looking over at this. So this is going to be PPV-BAT G3 hot connection, and it goes directly to this capacitor, and it looks like, I'm sorry, it is also going to connect here and here, but that doesn't seem right. We have a via, it's going to be going somewhere on the board. If we flip it over, it goes to pin 1, 2, and 3 on our battery connection, which eventually makes itself to Q7155, which is going to be our MOSFET that's responsible for letting power go to and from the battery. Let's revisit under the scope and see exactly what we got going on here. So according to our schematic, or our Flexboard View software, if we're to touch these two pads, they're supposed to be hooked together, and they're not. Let's touch the inside of that via. Yep, so this line is completely severed as well. But what it's supposed to do is if we flip it over, you can't see it because we've already have this populated, is they're supposed to be, these pads right here are all the same. They're 1, 2, and 3. And they eventually make their way over here to Q7155. So if we flip this over, these are going to be capacitors that kind of just help out with smoothing the alternating current into direct current. But it's strange because if we look at our board view software, it says that these two are supposed to be connected to each other. Let's just flip over a donor board and compare and see if that is the case. So here we have two perfectly unscathed capacitors, and if we touch these together, in theory they're supposed to beep. They are. So I wonder if we can just simply solder a wire from here to here. It's just strange that they have their own vias, instead of being connected together in one via. And that could very well be because there is 3 connections, pin 1, 2, and 3, are supposed to come here. So it's very odd, in my opinion, that these have 2 separate vias. And yeah, you can see if we touch these together, we don't get any beep at all. What is going to be the right way of doing this? Are we going to solder a wire directly to the via and then put our capacitor on there? Or could we, in theory, yeah, because here are where the pads go, could we, in theory, just solder a line together from here to here, because they go to the same place? I don't know why Apple did this. Because something is telling me that I should solder a wire to the via and not to this capacitor. It's just strange that they share the same line. Very interesting. Let's go ahead and just start working on soldering a wire to that via. Wrong camera. Where's the scope camera? There we go. I don't know. I feel like we could go either or on this one, so I'm really not sure why they did that, because it's the same line, and I can't really test. Oh, I mean, it looks like it comes from the same place, so was this an engineering mistake? Why was this done? Alright, let's see. We're scraping a little more into the via. Let's see if we get continuity between this one and here, and we don't. Oh, no, we do. So there is continuity between here and here. Okay, so, and it's a straight line. So that means, yes, in theory, being that these are both connected together, we should be able to just solder our capacitor here and bridge it to this capacitor, because they are exactly on the same line. I just don't know why there are 2 separate vias for the same line. It would be more stable that way too if we just solder the capacitor. I'm sure there is an explanation. I don't know what that explanation would be. The only thing I could think of is if this is supposed to be, let's say, for pin 1, that one's for pin 2, and these go directly to those capacitors from the battery. However, these literally share one giant pad right here, so it wouldn't really matter where the power from the battery is. Like the line from the battery, whether it gets to the this capacitor through the via, or if it goes off of this capacitor and kind of piggybacks off of here. I don't know. That is a question that I don't know how to properly answer. Let's go ahead and take this capacitor here. We will learn. We will put a capacitor in the replacement of the corroded one. We'll solder a wire, and then during the quality control test, we'll test and see how the battery is. And if we're getting any weird battery at all, then we can solder a via, or solder to that via. And let's make this one look pretty. So we could either do this, but but I'm not going to. We could either just put a giant blob right here connecting the two capacitors together, or we can solder a wire. I like the idea of a wire because it's going to be a little bit more structurally secure. So let me grab a wire. And what we're going to do is we're going to touch the wire on both sides of these capacitors. And it's got a thin enamel coating on it, so we have to melt that off a little bit. And now we cut off both ends. So we would just hold our scalpel down and just kind of wiggle this back and forth like you would a paper clip until it eventually snaps. Like that. So we no longer need our jumper wire. We'll set that to the side. And do the same thing onto this side. We're just holding in place, comes right off, and we're going to throw that piece away so it's not just laying around on our workbench. It would be really sad if we were to test this out and there was a wire on the workbench and it ends up shorting something out. Now, just because I'm being a perfectionist here, we got a mound of solder, I just want to touch this up. And really, it will kind of grab itself if we have a little bit more flux on here. So again, we're doing this mostly for aesthetics. Want this to look pretty, and we're going to put some mask on this at the office because we don't have any of that here. Awesome. So now that we have that cleaned up, before I get it with some isopropyl alcohol, what we're going to do is use our multimeter, continuity, make sure these capacitors are touching each other. They are. And let's make sure that we're not grounded, because that would be silly. The only reason I'm looking for that is because right here, when I scraped off part of the via, we can see that we've also exposed a little bit of ground. What is this? That is nothing important. Now let's clean it up with some isopropyl alcohol, and I think we're officially done with this one. I think it's ready for us to put back into the top case for testing out. We'll also need to look at the EDP connector. That's the display cable on the screen of the MacBook Air, just to make sure it doesn't have any signs of corrosion on it either. All right. And then, of course, we're going to give this one an ultrasonic cleaning. Not here, though. We don't have that here. Okay. Thank you, donor boards. You have served a good purpose. And we're just going to clean up our workstation here. So we don't need the solder right now. We're good with the wick. Good with cutting tools. No longer need the jumper wire. But it did its job, so we can put it back all the way up here. And then just so we don't get any flux on our top case, let's clean our general area. I just use high-grade isopropyl alcohol and a blue Scott paper towel. Mentioned you can get this in any automotive section or any automotive store. It's just a little bit more abrasive than a paper towel, so it really grabs things. All right, let's start reassembling. No longer need the fume extractor on. let's put this one back together and see if that fixed it. So supposedly here it's going to snow in words. Sorry, I can't speak. Supposedly it is going to snow until 7 p.m. tonight. That's the most snow that we've gotten in a very long time. And it doesn't really stay cold enough to stay as snow here in the south. What will inevitably happen is it's going to turn into ice. So a lot of businesses, even hospitals, or like urgent cares, they are closed tomorrow or opening late just because South Carolina drivers don't know how to handle snow. Even if we have salt on the roads, I actually saw it today when I was out walking, people will still drive as if the roads were perfectly fine. There was someone driving down the road next to my neighborhood, and they were going probably 60 miles an hour on a road that had a speed limit of 40 miles an hour. And just that type of mentality, that type of driving being so common, a lot of businesses are going to be closed tomorrow. So we are playing it by ear. We're either going to have a late morning, depending on if the sun melts any of the snow or the ice, not the snow, but the ice off the roads tomorrow. And if it looks really bad, then we are just going to have an extra day off, I suppose. I've had a few of those due to the holidays, more than I've normally get, and because I work 6 days a week. Sunday's the only day I have off, and even then I sometimes still go into the office just to take care of various things. Because not just doing repairs all day, there's also just administrative work. You know, it's the beginning of the year, so we have a lot of taxes we have to take care of, taking care of digital marketing. There's a lot that goes into running a repair shop. Very happy for it, don't get me wrong. But to be able to have a consecutive 2 days off, it's really, really therapeutic, really good for mental health. And mental health, in my opinion, is the most important type of health. Gotta steal the blue towel and nail polish remover trick. I definitely recommend it. And when it comes to nail polish remover, the acetone, you want to go with pure acetone. I know Walmart will sell pure acetone in the beauty salon or the beauty section. And I think we probably pay about $3 for a bottle, and a bottle lasts me about a year, 2 years, because you really don't use a lot of it. Just put a little bit on a Q-tip. Now the drive looks fine. No, actually, for a refurb, we're going to put a different drive in here. There is some corrosion on the SSD. I'm curious if this one will even load. We'll put it in just for the fun of it, because I don't have a test drive. I want to make sure that this slot is able to detect the SSD, hoping that there is an operating system on it for it to read. And to the naked eye, because I was talking about the EDP connection, it looks perfectly fine. It looks unscathed. Let's switch over to the scope camera so you can see what I'm talking about. So if we look right here at the EDP connector, it is surprisingly okay. So no need for us to replace that cable. That cable is a little complicated to replace. That would be a video for another time, but it involves removing the bezel of the MacBook screen without bending it, because it is metal, and getting to down here to where the hinge and the EDP connector actually plug into the screen, into the T-con board, which is conveniently upside down. So you actually have to remove the T-con board a little bit. It's a good skill to know, because you're able to replace the cable without replacing the entire computer. And if you can do a repair, you know, the less parts you replace, it's more economical for you as a technician. that you can pass on those savings to your clients. That way, when Apple tells customers that it's 90% the value to fix their MacBook, you're able to do it at a fraction of the cost. And the customers will give you a hug and write you a 5-star review because you performed a miracle that Apple said could not be done. Okay, let's get these in place. I'm having to get really close because don't have my glasses on, so I'm a little impaired at the moment. Great. So I only put one screw in the board because we're going to end up pulling the board out to give it an ultrasonic cleaning when we bring it to the office. We want to make sure that this still works with the battery. The battery does have glitter on it. There's a piece of glitter. I thought it was the LCIs, the liquid contact indicators. They're still white, so the battery hasn't been exposed to water in those general areas. So let's plug this in. The same thing with the battery, like I did with the logic board. I'm only going to put one screw in it because we're going to have to pull it back out anyways to give it a proper cleaning. And that should be everything we need connected to get this computer to work. So let's plug in our MagSafe, hit our power supply. Do we get a green light? We don't. We still get 0.03. Now remember, this was the initial issue we had until I removed the IPD cable. We cleaned the IPD cable and it did temporarily fix it, which is proving my point that the IPD cable will still need to be replaced. So just to show you, we simply unplug this cable. Now we hook up power. We have a green light. So this is pretty consistent, or at least I can see we have a green light. We also have a fan spin. You might not be able to see it, but if I do this, you can hear that it stopped. So let's take a look back under the scope, see if we can get it one more cleaning, just to get it long enough to work, to turn on. That's the wrong camera. Okay, so what we're experiencing is right here, this little guy had some oxidation that was preventing this from turning on. Let's just kind of scratch and expose. Exposing these wires. Not only are they oxidized, they are rusted. And as mentioned, we are going to end up replacing this cable. We're not going to send this out the door looking like this because while it is a band-aid repair, I'd like to call it, it is not a full fix. And then while we're at it, let's see if there's anything on the connector. From here, the connection looks fine. Still try to get something right here, because that is where the IPD cable goes into. Looks like there's some hair hanging out in it. Computers are gross. Someone asked me the other day, they said, "Do you always wear gloves?" And I said, "Yeah, phones and computers are gross." Has absolutely nothing to go on with the climate of the world right now. I've always worn gloves, even beforehand. If you've ever watched Mythbusters, they did a video where they proved that gloves or phones are actually messier than the common household toilet. So you're touching them all day long. It's gross. Okay, so now that we have that nice and connected and cleaned up, let's see if we get a green light. We do. So this is working just long enough for it to not turn on. No fan spin, 0.018. For the fun of it, let's remove the battery, make sure that's not what's going on here. Still 0.018, no light. So we are definitely having a bad IPD cable. So I'm not going to be able to test to see if the trackpad's fine until I replace the IPD cable. What we're going to do for now is we're at least just going to leave it out. We're not even going to worry about the battery. We're just going to plug this in, hold down the option button. We can't even hold down the option button now that I think about it because the trackpad is responsible for the keyboard. So we won't be able to hold down Option Boot. The only thing I can do is see if this turns on, we have a working backlight, and maybe even an Apple logo loading. That's the furthest I'm going to be able to test it here on the live stream at least. The rest of it I'll be able to perform a more in-depth quality control test. We even have a quality control list we go through with these refurbs to make sure everything is working afterwards. But for now, let's go ahead and plug in our power. See if we get a fan spin. We do get a fan spin. Let's see if we get backlight. If we get display. So we're getting 0.6 amps. The display just turned on. We have a kernel panic. And let's see if we get the Apple logo. More than likely, the kernel panic is from the previous liquid damage. The only thing is it going to turn on without the trackpad? I guess so. So we have an Apple logo, so the hard drive is being read. Just in case if there's a customer information on here, I'm going to cover it. There is a guest user account on here. This is a customer I am not familiar with, so I don't think this was a computer that we bought from a customer. I have a feeling this is one that we kind of bought in bulk. So this is a successful repair. Our fan is going to be running really, really loud because our trackpad's not connected. On top of the trackpad being responsible for our keyboard, there's also a thermal sensor that communicates to the system management controller in our trackpad. So the computer right now thinks it's on fire. So the fan is blowing full speed, but the cool thing is this one was able to be repaired. It's going to need a new IPD cable, potentially a trackpad. We won't know until we try a new cable first. And then we were able to successfully go through, clean up all the corrosion, replace any dirty parts on here. We just need to do an ultrasonic cleaning to make sure that this computer works. So I think that is successful. I think this is as good as this one's going to get. It is 3:24 local time for me. How long have I been going on this stream? We've been going for surprisingly 2 hours. Okay, I think this is a good point to cut. I have another board I have here, but I'd like to experiment doing another stream in the future instead of kind of getting them all done. And I'm sure my wife is awake from her nap, so we can work on building some frames for a photography exhibition that she's doing. So I think that's a good point to stop here today. I appreciate you all joining me today. It's been a while since I've done a live stream. I'm trying my best to be able to figure out a schedule or be consistent with doing streams just with the beginning of the new year, running a business and trying to look for more technicians to bring on board. It's a little difficult to balance work life, personal life, also bringing boards here at home. It's nice to separate personal life from work life. So when I'm bringing work home, it can kind of make things just a little bit complicated. But thank you so much for joining, and I will see you guys in the next one. Thanks so much. Be safe out there if you're in the winter storm. Have a great one.